Good afternoon, everyone. I am Mr. Ish. Thank you for joining me. We have done a number of limit videos, so we should be comfortable with limits. In this video, we can extend that concept by looking at limits at infinity. It may sound like it's a difficult subject, but for high school math students, particularly 12th grade, you should and you can be able to do this. It's not too hard. We have this function f of x is equal to arctan x. You would be given the graph of this. And even if you weren't given the graph of this, you could easily do it. Your arctan x looks something like this. You have horizontal asymptote here at y equals pi over 2, which you know is 90 degrees, and y equals minus pi over 2 minus 90 degrees. It always goes to the origin. Your graph would look something like this. It's just a rough approximation of it, and that's exactly the graph of arctan or inverse tan. You can look at it as this tan minus 1 x, synonymous. We have to find the limit as x approaches infinity, positive, and limit as x approaches infinity on the negative side. Just trace the graph and you would see exactly what your answer is. Limit as your x values approach positive infinity. As you keep going in that direction infinitely, where does your graph end up in terms of the y value, the range or the output? It approaches this horizontal asymptote and it becomes pi over 2. Limit as x approaches positive infinity, your function arctan x will approach pi over 2, and momentarily I'll show you how you can do this with the calculator. Limit as x approaches minus infinity, what happens here? Trace your graph here or your curve. As your curve approaches in the direction of minus infinity along the x-axis, the curve becomes very close to this horizontal asymptote, and the output value is minus pi over 2. And you can do this without the graph by the following way. Keep your calculator here on the DEG mode, degree mode. Come up with a very large value close to infinity. You can just do, how about this, all the 9s you can fit on the screen, and just do shift to involve the inverse and then the tan, and you get 89.99. So if you were to increase the number of 9s as I showed you, you would become 90. Now do the same thing here for a minus infinity. Bring in all the 9s you can on your calculator screen, but make a minus and do the inverse tan of this. Again on the degree mode, shift inverse tan to activate that, and you get minus 89.99, which you know becomes minus 90. So these answers are good. So you've now seen how you can do limits at infinity, and they're not very hard at all. Let's look at one more question and then we can be good with this video. We have as our second question just f of x is equal to e to the power of minus x. My tip to you all is this: if you are able to do these graphs, your limit questions become very easy, because all you have to do is read the graph and your answer is on it. When I'm looking at this, I'm thinking about something which was e to the x, which would look something like this going here to 0, 1. However, that's e to the x. But when I have e to the minus x, I'm looking at a reflection of this curve but along the y-axis, and suddenly my curve becomes this. And I erase this curve out of the way so we don't look at it any further. And that right there is e to the minus x. Now all you have to do is do these questions by means of the graph. Limit as x approaches infinity. You're going here along the x-axis towards the direction of infinity. Where does your curve eventually end up? It ends up very close to this x-axis, which you know is also y equals 0. So you know in terms of the output, as you go out there, this curve will get ever so close to this x-axis, an output value of 0, and that right there will be your answer. And again, I will show you everything here with regards to the calculator as well. Now how about this? Limit as x approaches minus infinity. When you're looking here in the direction of minus infinity, however, in this case your curve is going upwards, and it's going upwards to the direction of positive infinity, and that would be the answer for that. But let's look at this in terms of the calculator. You can come up again with a very large number, or what you can do is rewrite this as 1 over e to the x. When you do 1 over e to the x, now you plug in infinity, you're doing 1 over e to the infinity, which is 1 over infinity, which is 0, because 1 divided by a very large number is 0. And you can do this. What you can do to simulate this on your calculator is come up with like 2 9s and then do the shift exponential of it, and now do the reciprocal of it, and it'll be a very small value, 1.011 exponent minus 43. And that'll tell you as you put more and more larger numbers in the denominator, you're approaching 0. For this one right over here, there's not much you want to do here in terms of the calculator, other than all you can do is just put everything here into the function. You have e to the minus x, but if x here is a minus infinity, you're looking here at e to the minus infinity. The minuses cancel out. You're looking at e to the infinity, which you know is such a large number. Your answer would be infinity, and you wouldn't have to do anything more than just do this rough estimation. So this answer here is good, this answer here is good, and with that you have now learned this topic of limits at infinity and you have realized it's not that hard. Thank you for watching. Have a good day. Bye.